Hello everybody. Today we'll be going over units of measurement and we're going to mainly focus on the prefixes of SI units, and then we're going to do a couple examples where we convert from between one unit and another. So starting off, let's look at the prefixes. The prefixes of measurement, I wrote down a lot of the common ones here. You have kilo, centi, milli, micro, nano, mega, giga, and each of these would be attached to a base unit. So you would have kilometers or centimeters or kilograms and centigrams, and that's how that would work. And one way to think of it is if I say I have 1 kilometer. Well, if you look up top, you see kilo equals 10 to the third. So I put 10 to the third meters. So you get a nifty little conversion factor. You have 1 kilometer is equal to 10 to the third meters, or 1,000 meters. And this is where you get your conversion factor when you convert between units. So you could find this for each of the following prefixes, so you can convert between one and the next. So my conversion factor from, if I wanted to go from meters to kilometers, I would put, I have 1,000 meters per 1 kilometer. So this would be my conversion factor. If I went from kilometers to meters, I would have this as my conversion factor. The same exact thing, just flipped around, which, as you can see, is from this original setup you get from the prefix. So let's go into some examples. All right. First, let's convert 5,222 meters into kilometers. And I like to think of this as canceling it out. So I have a meters right here. So I'm going to put meters down here. And this is what I want to get. So I'll put kilometers. So that's what I'm looking for right now. And I'm going to pull that conversion factor from the other page, because I know that for every 1,000 meters, there's 1 kilometer. And then if you multiply this out, you get 5,222 over 1,000 kilometers times meters over 1,000 meters. And I want to show you the canceling out process, because you have both of these m's here and they're in the same fraction. So you cancel this out and then you plug in 5,222 divided by 1,000, and that's your answer. You get 5.222 kilometers. And look at that. And there is a way to check this. You can invert your conversion factor and return it back to meters, because you know that every 1 kilometer is 1,000 meters. So if I have, 5 kilometers, that's 5,000 meters. And if I have 0.222 kilometers, that's 222 meters. And if you add this and this, you get your original starting length, which that's how you know you're right. And next, let's go from a little bit tougher one. You don't see nanometers as much usually, especially in introductory physics. So let's do that. So remember, I want to cancel out my meters, so I'm going to put meters on the bottom. And now I'm looking for nanometers this time. So nanometers will go on top. And this conversion factor you'd have to do, you can either pull up a table, or if you already know the value, that's great. And I know that for every 1 meter, there's 10 to the 9th nanometers. And this makes sense because nanometers are really, really small. So there should be a ton of them in 1 meter. And that would equal 5 times 10 to the 9th nanometers. I am going to keep it in scientific form, so I don't have to write a million zeros. But feel free to write it out, whichever way is easier for you. And next, we're going to convert from centimeters to kilometers. And when I do problems that go from like centimeters to kilometers, or say kilometers to nanometers, I always bring it back to meters. I find that to be a lot easier because then I can always use the same conversion factors. I get it to meters, and then I get it to where I want to go. So that's what I'm going to do here. First, I'm going to convert to meters, and I know that for every 100 centimeters, there's 1 meter. So that will cancel out my centimeters terms, and that would equal 0.57 meters. But I'm not done yet, because I need to get to kilometers still. So let's do this. I want to cancel out my meters, so I'll put it on the opposite side. And I want to get kilometers, and I know that for every 1 kilometer, there's 1,000 meters. And this will equal 0.00057 kilometers. Which makes sense because a centimeter is already only about half a meter, and if a kilometer is 1,000 of them, it makes sense that it's a really, really small number. And again, you can check these by flipping your conversion factors and re-solving back for your original input. But that would be a good exercise for you to do by yourself, because you know, just to get the hang of it. And now we're going to do a little bit tougher of an example. We're going to go from, first of all, from kilometers per hour to nanometers per second. And these are uncommon factors. I don't think I've ever seen anything in nanometers per second. But just the process, so you can get the hang of it, I think will be great for showing you and practicing your conversions when it comes to units like this. All right, so first, I'm going to deal with the time first, because that's always the same no matter what's above it. You know how to fix the time. So now I want to cancel out the bottom term. So I'm going to put 1 hour up here. So I'm going to cancel my hours this time. And I know that in 1 hour, there's 60 minutes. All right. Still not in seconds, though, so I'm going to have to cancel out my minutes, too. And I know that in 1 minute, there's 60 seconds. So my minutes cancel out, and that leaves me with kilometers and seconds. So I'm going to multiply that out to get rid of, so I don't get a really long term. So 75 divided by 60, divide that by 60, and you get 0.0208. I'll leave the 3 repeating in there for now. You get 0.0208 kilometers per second. But we're not to nanometers yet, so now let's focus on moving our kilometers term, converting that over. I am going to shorten it to 0.0208 and just can't get rid of the 3 for now. So I have kilometers over 1 second. And now I'm back to canceling out the top term. So I'm going to put kilometers down here and then meters up here. So 1,000 meters per 1 kilometer. Those will cancel out. And then I need to get back to nanometers. So I need to remember how many nanometers are in 1 meter, which is 10 to the 9th. Oh. See, it's easy to flip these around all the wrong way. As you can see, I just did. But it's 1 meter for 10 to the 9th nanometers. And this will give me, once the meters cancel, I'll be left with nanometers per second. And that's what I'm looking for, so that's great. So let's put this through the calculator. And you end up with 2.08 times 10 to the 10th nanometers per second. And that makes sense again, because nanometers are really small. So it makes sense that you're doing a whole bunch of them, because you're going 75 kilometers per hour. When you transfer it to nanometers per second, it still should be a very large number. But now let's do this to another odd conversion, which would be meters per minute. So again, I'm going to do the time first. So 2.08 times 10 to the 10th nanometers per 1 second. I'm going to multiply that by 60 seconds per 1 minute. And then, as you can see, that will cancel out my seconds terms, leaving me with minutes. So I have one of the terms I want. But now I need to get rid of nanometers. And you'll see that I just flip around this term up here so I can convert back to meters. So I know that 10 to the 9th nanometers are in 1 meter. And when you multiply this out on your calculator, you get, divide by 10 to the 9th, you get 1,250 meters per minute. Now, I hope this was helpful as you get to learn units and start doing dimensional analysis. It helps a lot just by even running through a few examples that are similar to these. Just convert from one and then back so you can check your answers. If you have any questions, please leave them in the comments below, and I'll try and look at them and respond so I can help you guys out. But otherwise, I believe that is all. I hope you guys all have good luck in your math. Bye.